All right, we're on air. All right, let me get to the quiz real quick. All righty. All right, did you actually participate? Just kidding. I wonder if Justin's even in the class anymore.
You mean Jake?
Or Jake, you're Justin. Sorry, dude.
Yeah. I don't know. I haven't heard. I still have never heard from him since
Yeah.
the beginning. And he was the one that first reached out to me, so that's why I was kind of surprised that he ghosted us. But okay, so question 3. We're using the applet, right?
Mm-hmm. So these first couple ones are just. So the number 3 is the total area under a normal distribution curve.
Oh,
must equal.
That's
it's 1.
1, right?
Yeah. And then number 4.
That's false.
Yeah, that's false.
Can't go down.
Normal distribution curve is symmetric. That's true.
Symmetric.
All right. So then the next 2 questions you have to use just the picture.
Right.
So the z-score is C.
Right.
And then the next one, number 7, greater than 0.1 is B.
Mm-hmm. According to the 68, 95, 99.7 rule, the percentage of the data bell-shaped curve will be within 1 standard deviation of the mean.
And that's 68%.
Percentage. Right.
So that one's 68. Number 9 is where you use the probability applet.
Mm-hmm.
Sorry. All right. So when I
proportion of z-score will be between -1, 1. So just the area, right?
Yeah. So you just click on the center, correct? On the.
Yep. I believe so. It's 0.6827.
Let me see, make sure that's what I got. Yeah, it says to do 3 decimal places, so just 0.682.
Okay. 68. Well, that would be 3, wouldn't it?
682.
Since you round up, or does it not say?
I don't know. It doesn't say to round.
Accurate to 3 decimal places. Yeah, it doesn't say anything about rounding. I guess
we'll find out.
Yeah.
At least we get 2 chances.
Yeah.
In case we have to go back. All right, so 0.682. Then the next one is -2 and 2.
0.954 or possibly 55.
I hate some of these, like you get them wrong. It's like, what? Like, come on.
Right.
Yeah, so 954.
Okay, we're on 12 or 11 now. Between -3. 0.997.
Mm-hmm. All right, so question 12. Look carefully, answers this 3 question. What do you observe? And if you look at all of them, it's 68, 95, and 97. So should be the match the rule, right?
Look carefully at the answer. Yeah, exactly. Yep.
Yeah.
So, but it does want it to 3 decimal places. Okay. a little confused about the rounding, but I'm sure we'll figure that out once we hit submit.
Well, it doesn't say round though. It says accurate to 3 decimal places.
Okay.
So what is accurate? Just means just 3 decimal places, right? It doesn't say round.
Yeah, I think it would say round. I don't know.
All right.
Let's see here. So we're on 13 now?
Yeah.
Okay. So I'm just going to read the little scenario here.
Go ahead.
The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 0.65 grams, and the population standard deviation is 0.07 grams, and then all that. What proportion of the population have a protein requirement that is less than 0.6 grams? So we need to find the z-score, right?
Yeah. So can we use the...
So we're using 0.6 as our value. That's x, minus the mean, which is 0.65, divided by the standard deviation, which is 0.07. So that'll be negative 0.05 divided by 0.07. Calculator here.
So how'd you get that one?
So you just use that equation.
Which was?
Z-score equals x minus the mean over the standard deviation.
Sorry, I lost my headphone.
That's all right.
Say that again.
So that is x, or z-score equals x minus the mean, or the mu symbol in the book, over the standard deviation. And then you just plug in the mean and the standard deviation, and you can look up your x as your value that you're looking for.
So it's pretty much the mean, or wait, no, the standard deviation times the z-score, and then plus the mean.
No, so we're not doing that quite yet, because that would be
that's you're trying to find the
right. So okay. we already have the value. X is 0.60. That's what we're trying to find the z-score for.
Okay, so then in the normal probability curve we put what?
So then in the applet, I found the z-score is negative 0.714.
Okay, so
then we put that in the applet.
Negative 0.714.
And then what we want to do, 0.714, is what proportion of the population have a protein requirement that is less than 0.6. So we've found the proportion that it would be everything to the left of, so you'd want just the very left area.
Okay. So you got 0.237. Okay.
Yeah. Or if it's rounded, 0.238. I might have to go through and round everything if it's all wrong.
Okay, so this one's more than 60%.
So then we just take
0.6.
Yeah, so then it's 1 minus 0.237. And that's 0.763. And then it looks like we're doing the exact same thing, only for 0.7 grams. So this is probably going to be on the kind of the right side or the higher side. So then we do 0.7 minus 0.65 over 0.07. And that will be 0.7. Yeah, so basically it's still 0.714. It's just now it's basically switched actually. So now the proportion is the same as what's not.
So
that's interesting.
We just do the z scores, the 0.74, but then we're trying to find the greater than, right?
For this one, we're trying to find less than, so it'd still be 0.763.
Oh, less than. Oh,
so it'd actually be the same answer for 14 and 15.
Yeah. Point. Wait, what did I do wrong?
0.763. Yeah.
Oh, okay, I got it.
Or did I?
Wait, no, because less. Oh yeah, less than 70%.
So the reason why that is because the standard deviation is, the mean is 0.65, and so for 0.6 we're 0.05 grams to the left of the mean, and for 0.7 or 0.05 to the right.
Mm-hmm.
So that's why it's the same proportions. Let's see here. Are you still confused about that one?
No. Well, I have points. Did you get 0.7624?
That's what the applet says, but did I round? Because then on number 13, 0.237, the opposite of that, or it would be 1 minus 0.237. That's how I got 0.763.
Yeah.
So I don't know.
Well, should we go with what's in the applet or what's in?
Well, for maybe, I'm just going to keep them the same because that should be the same.
It should be.
It's weird. I found the same differences in the homework too, because I used the applet, but then I looked at the homework key, and it was like 1/1000th off, like this. Yeah. So I don't know why that's happening, but.
So I wonder. I don't know. I guess I'll put 762, and you put 763.
Yeah. Let's try that, and then. Yeah.
All right. Okay. So the next one.
That's 14 and 15, right? So we'll
get. Yeah.
Okay. Just gonna mark that down here.
So find the probability.
Yeah, you want to read 16?
Yeah, sure. Find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70. Let's see. It says remember to find the area between the two values. Shade to the left of each z-score. You calculate, then subtract the smaller area from the larger area. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values.
So for this, it's actually kind of made it super easy on us because we can check our answer since they're equal from the center. Because basically we're going to take, I think what we're going to do is take, so from 0.6, the area below 0.6 is it's going to be the answer of question 13. So 0.237. That's the area below that. Then the area below 0.7 is 0.763, maybe 2, we don't know. And then you just subtract 0.763 minus 0.237, and that should give you the area in between. What's interesting is the probability applet, you can just click on the middle, and 0.52. I got 0.526 if we're...
7.
The applet says 0.524. If you round it, 0.525.
Yeah. I got 525.
Yeah, I think that's what I'm going to put too.
Yeah, I'll try.
Okay, question 17. Find the 35th percentile for the protein requirement for adults. Round your
35th percentile.
For this, since the area represents the proportion, we can just put 0.35 in the area and then get everything to the left of, it'll be to the left of the -1. So you won't include the middle because it's the bottom 35.
So you'll do the...
So this is where we're gonna use.
You click the area to the left, right? And then you do 0.35 in the applet. And then you take
in the area.
And then you take
0.35.
But you do.
Then you take the z-score. Yeah, so it's going to be a negative z-score.
That's right.
Of 0.385. 0.385, and we're trying to find x. 5 equals x, and then it's x minus, we're still at 0.65, right? Is the mean, yeah. 0.65 over 0.07 is the standard deviation. So then, and it's going to be a negative 0.385. So we're going to we're going to multiply negative 0.385
times 0.07.
Is 0.07, and then we're going to add 0.65.
And 0.623. So you got?
Yep.
All right.
That's what I got. Okay, I think we do the same thing for the next one, the 80th percentile. We're going to go to the applet, type in for the area 0.8, and then we're going to use the positive z-score this time.
So we're doing both the middle and the side. That's right.
Yeah, so it'll be a positive 842, sorry. 842 equals x minus 0.65 over 0.07. We're going to take 0.842 plus, or sorry, times 0.07 plus 0.65. And
0.708 or 709.
Right. I've been rounding the whole time, so we'll see.
You'd think they would. It's got if it. I don't know. So see, this one says round your answer.
Oh, it does say round.
Yeah.
All right, so let's see what happens.
709. Now that one says round. The other one doesn't matter. The other one. Let's see.
Okay. So it was around. Okay, so question 9. Did you get that right?
Let me see. Hold on a second.
Because I didn't.
Let's see here. All right. Hey, I got number 1 and 2 right. That's pretty good.
Well, that's good. I think I got one through 7 right. Or sorry, 1 through 8.
9. No, I did not get 9 right. And you put 0.682.
So we probably should round.
Yeah. Oh, and I missed question 10.
Same.
Yeah.
I put 0.954.
And we didn't round those, right?
Correct. Yeah, we didn't round them.
Okay, so those have got to be.
We've got to round that. Okay, what about 11? You get 11?
Let me see here. I got 11.
Okay.
I got
12. That's pretty
12.
easy because it should be 997.
Yeah.
12. Okay.
12
13.
I got. 13, yes. 14, yes. 15, yes. 16, yes. 17, yes. 18, yes. So, yeah, it's just those two.
Wait a minute. Yeah, just those two.
So, sorry, man. Yeah, I should have listened to
you.
you.
That's all right. No, that's fine. Yeah, I think what we'll do is we'll just go back and round them and then all good.
All right.
All right. We'll see you
Probably just do that on our own. So
Monday. Yeah, I'll just do it.
You want to set it up next week?
Yeah, I can do that.
All right, cool.
Monday at 8.
All right, man. Have a good night. We'll see you.
See ya.